Hello, my dear students. Welcome back to my class. In the series of learning data structures through C, in the previous video, we discussed about the Q program. Well, it was a long gap because I was busy with the content of second PU. So you all know second PU exams are going on. Karnataka State Board second PU exams. So I was quite busy in preparing the content of computer science subject. So we will continue with the data structure series from today. Well, in today's video, we will be discussing about a new topic in the data structure, that is linked list. So we have dealt with stacks, we have dealt with queues. So we have seen the static representation. Now it's time to see the dynamic representation. So we will be learning about the introduction to linked list in today's video, and also we will see the difference between static allocation and dynamic allocation. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end, do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. So let's get started with the introduction to linked list. So before we get into the linked list, let us learn why we have to get into this linked list concept. So, well, we have learned about the linear data structure. So, we have learned about the linear data structure such as stacks and queues, which are represented and implemented using sequential allocation technique using arrays. So, we have seen the memory representation. So, how the data inside the stack, data inside the queue is represented inside the memory. So we have two different methods to represent the data inside the memory. There is a memory representation of stack, and the memory representation of queues is dealt in two ways. One is static representation, that is using arrays, that what we have dealt in the previous video. Please do check out the playlist. And the second method is the dynamic representation, that is done with the help of linked list. So why we need to switch over from the static representation to dynamic representation? Let's have a fast glance on that, and what actually this static allocation, what actually this dynamic allocation, let's see. Okay, so we have seen stacks and queues, and we have also learned how to represent that inside the computer's memory using arrays, that is using static representation. So what happens in sequential allocation technique? It is quite simple and it is quite efficient also, only when the memory to be allocated is pre-known. So when I know the amount of memory that what I need to allocate, if I am confirm with the amount of memory that what I require for my program, then I can simply go with static allocation. But sometimes I cannot predict the amount of memory I require. So for example, I know that in my class I have only 10 students for C language. Only 10 students for C language. Then I can predict that count. But when I cannot predict that count, there are many students coming in, many batches I need to create. I cannot predict the number of count, right? The total count of students. In such case, I have to go with dynamic allocation when I cannot predict the total number of entries. So in such case, we cannot go with the sequential allocation. Of course, sequential allocation technique works efficiently. The amount of memory that what I want to allocate is well known to me. In such scenario, sequential allocation works very good. And the data items are also accessed efficiently using the index value. So you have the index which always starts from 0 to n minus 1. So we know that with the reference of index only in the sequential allocation technique, the data is accessed. And stacks and queues, when they are represented in the memory using arrays, using the static allocation technique, has a major disadvantage here. Means, I say I have 10 students in my classroom, and I allocate 10 chairs in my classroom. But the 10 students are not coming to my class. They just have to attend for some days, and for another some days they'll take leave, or they have some urgent work or something like that. So in such scenario, what happens? The chairs that what I've allotted there will be wasted, right? And I said 10, I have maximum 10 chairs with me. If it is less, I can manage somehow, but it will be getting wasted. But if it is more than that, if it is more than 10, I cannot allocate space. Just imagine you have a queue counter where only 10 people can stand. It can be less than that also, but it cannot be more than that. So it says the major disadvantage here in the static allocation. So when stacks and queues are represented inside the memory using arrays, the major disadvantage is the array has a static structure. See, arrays are static data structure, and therefore it's quite difficult. It cannot be easily extended nor reduced to fit the data. I say I have an array to store 5 elements, maximum 5 elements, 1, 2, 3, 4, 5. I can store less than that. If I store less than that, memory resource is wasted. But if I want to store more than that, I cannot, because it is fixed. It is fixed. I cannot adjust that memory. So in static structure using arrays, it's quite difficult to increase the size or decrease the size. So insertion and deletion is also quite difficult. We all have seen how to do the insertion and deletion using arrays. Using stacks and queues, we have seen how to insert the element. We have seen how to delete the element. So the insertion and deletion process can be done, but it's quite complex. The code that what we write is very lengthy. We have to think over about the logic. So the logic implementation is very complex in case of static data structure. So if I represent the so-called data structure stacks and queues using the static allocation, it is good if I know the size. The size is well known to me, and I am very much sure that I am not going to increase nor decrease. Then I can simply go with arrays. But if you cannot predict the size, then I have to go with dynamic structure. So as static allocation is having all these disadvantages, it's better to go with dynamic memory allocation. So linked list is used, which uses dynamic memory allocation. So the stack data structure and the queue data structure, both data structure can be represented in two ways, static way and dynamic way. Static way, it can be represented using one dimensional array, and if it is using dynamic way, then it has to take the help of linked list. So if stacks and queues are represented in the memory using static memory allocation, then it uses 1D array. But if it has to go with dynamic allocation, then it has to take the help of linked list. Along with linked list, pointers concept is also required for dynamic memory allocation. So totally for dynamic memory allocation, we require two things. One is linked list and the other one is pointer. See, in arrays what happens? Memory is allocated continuously. Static allocation, fixed allocation, memory is continuous. Consecutive memory allocations we get, continuous memory allocations. But when I go with dynamic memory allocation, the memory is not continuous. The memory is randomly allocated. It is allocated randomly allocated. So allocated randomly means wherever free memory it is going to get, that free memory it is going to fetch. So in the dynamic memory allocation, what happens? The memory has to be allocated Dynamically means that is during run time, during execution time, the memory will be allocated. How the memory will be allocated? How this dynamic allocation is done? All those things we have to learn one by one. What actually this dynamic memory allocation is and how actually it has to be implemented, we have to see along with the help of linked list and pointers. This dynamic memory allocation will be done. So as the memory is allocated randomly, with the help of pointers, it has to be linked to each other. So pointer is a special variable which holds the address, right? So it is the one which can point to the randomly allocated addresses. Okay. So as the static allocation is having all these disadvantages of fixed size and memory is getting wasted, the memory cannot be adjusted. So we have to go with dynamic memory allocation. Dynamic memory allocation is nothing but allocating the memory dynamically, that is during runtime, which is called as execution time. So in dynamic memory allocation, the size of the memory can grow or shrink during the execution of the program. So during the runtime process, during the execution of the program, the memory is allocated. It can grow or it can shrink. All these happens during runtime. So dynamic memory allocation and linked list representation. So dynamic memory allocation and linked list representation is used when we cannot predict the memory required. When we cannot predict the memory requirement. The amount of memory to be allocated is not known to the user. We cannot predict it. In such case, we go with dynamic allocation, and for that, linked list and pointers are going to help. So let's have what actually this static allocation and dynamic allocation. The most frequently asked question in your degree courses or in your engineering courses. Write the differences between static allocation and dynamic allocation. So let's see that. So let's understand the difference between dynamic memory allocation and static memory allocation. Static memory allocation we have seen. So we need to understand what is dynamic memory allocation. So as I said, in a simple terms, you need to understand it is the memory which is allocated during runtime. So I can allocate and deallocate as I require. According to the user requirement, according to the program requirement, the memory is allocated and deallocated. Means the memory is used efficiently. So let's talk about the differences now. So in static memory allocation, the amount of memory to be allocated is pre-known. How much amount of memory I need to allocate? So it is known to me earlier itself. It is pre-known. But the amount of memory to be allocated is not known. It is not known. I cannot predict. I cannot predict the amount of memory in dynamic memory allocation. Then, memory allocated during compile time. During compile time, as when we try to understand the program, always we say during the compilation, the memory is allocated like this, the memory is given to these variables like this, right? So during compile time, the memory is allocated means it is static allocation. But actual saying, all the memory will be allocated during runtime itself. But the amount of memory to be allocated is fixed during compile time. That is during the compilation of the program. See, we say int a of 10 means it is fixed. Maximum 10 elements I can store. So the memory has to be allocated to store 10 elements based on the data type. If it is integer array, so if it is the machine that what we use, it depends, 32-bit machine or 64-bit machine, it may be 2 bytes or 4 bytes. If it is 2 bytes, totally 20 bytes of memory will be fixed for allocation. We cannot change that. We cannot increase that, nor we cannot decrease that. We cannot precise it also. So once the memory is fixed, so we just said it's compile time. Means to say, you need to understand in such a way that during compile time, the amount of memory to be allocated is fixed. Allocation will be done during runtime only, but the amount of memory to be allocated is fixed during compile time. I say int a of 10 means totally if it is 2 bytes, 20 bytes of memory is fixed. I cannot increase that and nor I cannot decrease that. Okay. But here memory to be allocated is decided itself during runtime. It is decided, it is not fixed, it is decided during runtime. So where do we get that memory? We have to see that later. When we get into the dynamic memory allocation, we will completely understand how the memory is allocated during runtime, from where it is going to get the memory during runtime, how this random memory allocation is done, how we can deal with dynamic memory allocation. We have to see that in detail. The next coming videos we will be discussing about that. Next, the amount of memory is fixed, but here the memory is not fixed, because here the amount of memory is fixed means if I just say 10 elements I want to store, that is fixed. But here the amount of memory to be allocated is not fixed, means allocation and deallocation, everything is decided during runtime itself. How to allocate, how to deallocate, we will see that later. Next. So this is inefficient use of memory. Static allocation, it is inefficient use of memory. Because I said 10 elements, but the user may store only 5 elements. What about the remaining memory which is fixed for storing another 5 elements? It is simply wasted. Memory resource is simply wasted. But if I say I want to store 12 elements, that is not possible. So memory is not utilized properly in static allocation, but here we have efficient use of memory, where in dynamic memory allocation. Finally, wastage of valuable computational time. See, we say during the process of insertion and deletion, we do the various process of shifting the elements to higher order, lower order. We swap the values again and again. So many process takes place because logic is quite complex. So implementation of that, the time required to process that is more. So it says the time is getting wasted for computational process. So for the computational process, time is getting consumed more. But here it reduces the computational time. Less amount of time is required for any computation because memory is not wasted. See, in static allocation, we have to go in the linear order itself. So it is linear allocation where insertion, deletion, everything takes place in linear order itself. But in dynamic allocation, it's not like that. Memory is allocated itself randomly. I can switch to one memory to another memory from any direction, maybe from the beginning, maybe from the ending, or in between. The computational time is very less. So this is what the difference between static allocation and dynamic allocation. So let's get into this dynamic memory allocation discussion and what actually this linked list is, how to use this linked list with dynamic memory allocation. We will see all these things in the next coming video. So stay tuned to my channel. Okay. So that's all for today's video. See you in the next video. Till then, take care. Bye bye.